Hello students, good morning. Today we are going to learn how to draw Lewis electron dot structure, as it's a very important topic in inorganic chemistry of both class 11 and 12. So before we start, let us know what is Lewis-Kozel theory. According to Lewis and Kozel, these two scientists, they said that when atoms of same or different elements chemically combine together to complete their octet, that is to have 8 electrons in their valence shell. During the formation of molecules or during the formation of any compounds or say anion or cation. So they will chemically combine together to complete their octet, that is they will have 8 electrons in their valence shell. Now before we start drawing the Lewis dot structure, we must keep certain points in our mind. So what are the points? We are going to list the important points. First, our first point is we have to focus only on the number of valence electrons of the participating elements. That is, we are not interested in the number of electrons present in the inner shells. Our focus will be only on the number of valence electrons of all the elements, that is the combining atoms, right? So while drawing the Lewis dot structure, we are representing only the valence shell electrons. Second point that we must keep in mind, we have to complete the octet of all the atoms including the central atom. That is, octet rule has to be completed of all the participating atoms including the central atom. So for other atoms it is 8 electrons after sharing. Only for hydrogen it is 2 electrons. Why? Because hydrogen will try to attain the structure of helium configuration, means it will have the nearest noble gas configuration of 1s2, helium configuration, and that is why for hydrogen it is duplet. Now next is for central atom. Now this is again so much important, students. Central atom can have 8 electrons or even more than 8 electrons. Central atom can have 8 electrons during the formation of ions or molecules, or it can have more than 8 electrons. So central atom will have the tendency to remain in its maximum covalency state. And to remain in its maximum covalency state, central atom can even violate the octet rule. This is very important. So let us know, there are some cases where we can show that octet rule is being violated. For example, we have elements sulfur, phosphorus, where the maximum covalency can be more than this. Means we have sulfur, maximum covalency is 6, phosphorus, maximum covalency is 5. For chlorine, maximum covalency is 7. Oxygen, maximum covalency we always know that is 2. So these are the maximum covalency state. We have seen that for central atom will try to have the tendency to remain in its maximum covalency state, and to remain in its maximum covalency range, it can at times violate the octet rule. So now we will learn how we are going to show the Lewis electron dot structure of nitrate ion, nitrite ion, carbonate ion, phosphate ion. Let us list the rules. First we are going to take up rule 1, rule 2 step by step in this manner. Now step 1 is first calculate the total number of valence electrons of the species. Over here species means it can be an anionic species, cationic species, or even neutral molecules, and that is denoted as Q. So what we are doing first, our first step is we are calculating the total number of valence electrons of the species. Okay, then second step, step 2, select the central atom as per the rule as per the property of central atom. That is, suppose we have an anionic species, for example PO4 3 minus, SO4 2 minus. Now what can be the central atom? Definitely for sulfate, sulfur is the central atom, and for phosphorus, phosphorus is the central, phosphate, phosphorus is the central atom. Why? Because central atom, as per the property of central atom, it must be in least in number and least electronegative. Central atom should be least in number in the species and it must be least electronegative. So we have selected the central atom, we have calculated the total number of valence electrons of the species, right? Then step 3. After calculating the total number of valence electrons and selecting the central atom as per rule, we draw the skeletal structure of the species. Now, how do we draw the skeletal structure of the species? By using only single bond. Connecting the central atom with the corner atoms or terminal atoms, right? Then next, step 4. So we have drawn the skeletal structure of the species. Our next step is calculate the bond pair electrons. From the skeletal structure, we are going to calculate the bond pair electrons. Okay, now as we calculate the bond pair electrons, it will be followed by calculation of lone pair electrons, that is Q minus bond pair electrons. Now this is again so much important. So what did we do right from the very beginning? We have calculated the total number of valence electrons of the species. I'll take up examples after completing the rules. So first is we are calculating the total number of valence electrons of the species. Second is, as per the rule of central atom, we are choosing the central atom least in number or least electronegative. Third is, by connecting the central atom along with the corner atoms or terminal atoms, we are drawing the skeletal structure of the species. This is not really structure. We are talking about skeletal structure where we are connecting the central atom with the terminal atoms only by single bond. No double bond, no triple bond, no lone pair, nothing. Fourth step, from the skeletal structure, we come to know the number of bond pair electrons. This will be more clear when I take up examples. After calculating the bond pair electrons, what is my total number of electrons, total number of valential electrons? Q, I have already calculated in the first step. So now I am calculating the lone pair electrons, that is Q minus bond pair electrons. Okay. Now, as I get the number of lone pair electrons, my step 5 will be easy. I use this lone pair of electrons in two ways. Then use the lone pair electrons in two ways. How? First, complete the octet of terminal atoms. First complete the octet of terminal atoms. And then the remaining will be utilized in completing the octet of central atom, and then if we are unable to fulfill the octet of each of the participating atoms still, then convert a lone pair of electron from a corner atom into a double bond. After that, we are going to put the charge according to the concept of formal charge. So till here it is clear. So we are going to the first page once again. So next year. So before this, we will tell you one more important point is that regarding central atom, hydrogen and fluorine. Mark the words, hydrogen and fluorine can never be central atom. Hydrogen and fluorine can never be central atom. Nitrogen can be central atom. Even oxygen can be central atom. Phosphorus and sulfur, they can also be central atom. Chlorine also. But we cannot have hydrogen and fluorine as the central atom. And what is the characteristic of central atoms? It will have the tendency to remain in its maximum covalency state. And to remain in its maximum covalency state, it can even at times, as per the need or necessity, it can even violate its octet rule, right? So now we are going to take up examples. So first let us start with NO2 minus. This is nitrite ion. What happens in inorganic chemistry, it requires a lot of learning. Now as we practice more, we will become more and more proficient. So this is our first species, nitrate ion. So what was the rule according to it? The step 1 is calculate the total number of valence electrons. So total valence electrons of the species equals to nitrogen, number of electrons in the valence shell 5. How many oxygen atoms are there? 2. So 6 into 2, as it has one negative charge, I add 1. So over here I am getting 12 plus 5, 17, 18. 18 electrons. So total valence electrons of the species of nitrite ion is 18 electrons. Now next is step 2. Step 2 was what? Choose the central atom. So according to the structure, our central atom is nitrogen, right? Because we can definitely say that nitrogen is least in number, and over here nitrogen is taken as the central atom. Now from this we are drawing the skeletal structure of nitrite ion. How to draw the skeletal structure? I take nitrogen as the central atom and show 2 oxygen atoms and draw the skeletal structure only by single bond. Step 3, this is the skeletal structure. Now next is step 4. So what was step 4? Calculate the bond pair electrons from the skeletal structure. So we have the skeletal structure, and from there we are going to calculate the bond pair electrons. So according to the structure, bond pair electrons will be how many? See, oxygen single bond, nitrogen oxygen single bond over here and single bond here. So we are getting what? 2 and 2, right? 4. So our bond pair electrons according to the structure is 4. Now from here we are going to calculate after this what? Lone pair electrons, right? Next, lone pair electrons will be equals to Q minus bond pair electrons, that is 18. We got Q, the value of Q was 18 electrons of the valence shell and bond pair electrons were 4. So over here we are getting 14 electrons as lone pair, right? Now this step is very important. From this now we are drawing the structure. Again nitrogen, oxygen, single bond. Now these lone pair of electrons, 14 lone pair of electrons, we have to utilize in 2 ways. How? Satisfy the octet of terminal atoms and then double bond, triple bond as per the need, or and central atom as well if with the remain. So let us see, already there are 2 electrons for this right oxygen. So I am going to put over here 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen on the right, its octet is fulfilled. Now let's come to the oxygen on the left. 1, 2, 3, 4, 5, 6, 7, 8, right? So oxygen on the right and on the left, its octet is fulfilled. So we are left out with, so 14 electrons we had as lone pairs, but how many electrons we have utilized? 6 and 6, 12. So we are still left out with remaining 2 electrons. Now check nitrogen. Nitrogen over here we are having what? 1, 2, 3, 4, 4 electrons. If we utilize the remaining 2 electrons which are left out as lone pairs, what will happen? Still we are not being able to complete the octet of nitrogen, right? See, 1, 2, 3, 4, 5, 6. So oxygen's octet is completed, both the oxygen atoms, but we are unable to complete the octet of nitrogen. So in this case, what is to be done? Convert one of the lone pair of electrons of oxygen into a double bond, and now we check the total number of electrons for each of the atoms. The participating atoms are nitrogen and oxygen. For the left oxygen, 2, 4, 6, 7, 8. There are 3 lone pairs, we can say 6 electrons and 1 bond pair. Over here we see 1, 2, 3, 4, 5, 6, 7. So 2 lone pairs and 2 bond pairs. Now let's come to nitrogen. This is our central atom. 1, 2, 1 lone pair, 3, 4, 5, 6, 7, 8. So our structure, we have completed the octet of every atom over here, right? So this is how we can draw the Lewis electron dot structure. Now next, coming to, as it was nitrate ion, what about the charge? NO2 minus it was, isn't it? Whenever oxygen is connected to the central atom by single bond, when oxygen is connected to the central atom by single bond, we put negative sign, negative charge over here. When oxygen is connected to the central atom by double bond, then charge is 0. This oxygen carries 0 charge. Okay, so over here finally we can draw the structure as This can be further explained by the concept of formal charge. When we have got cationic or anionic species, where to put the charge, which atom, individual atom will carry which charge, that can be calculated with the concept of formal charge. Okay. So now we are going to have a brief concept on formal charge. What is formal charge? In case of polyatomic ion, we represent the charge, overall charge, as a charge on the ion as a whole. But if we need to calculate the individual charge carried by the atoms in the ion, we can also calculate. So these are basically, formal charge is basically the apparent charge of the individual atoms that we are showing. So how do we calculate formal charge of the individual atoms? Total number of valence shell electrons of the atom minus lone pair of electrons of the atoms minus bond pair of electrons by 2. From this formula, we can calculate the formal charge carried by the individual atoms in the ion. So from here, we are going to apply the formula of formal charge to calculate the charge of the individual atom in case of nitride ion. So in the last case or the previously, we have drawn the Lewis dot structure of nitride ion, right? So let us number it atom 1, and this we go for as atom 2 nitrogen, and oxygen, the second oxygen, we number it as atom 3, and see how do we calculate the formal charge. So for this first oxygen 1, how do we calculate the formal charge? Total number of valence shell electrons in case of oxygen, it is 6, minus lone pair of electrons. How many lone pair of electrons? 2 lone pairs. So that means total number of lone pair of electrons 4 over here, right? And then minus bond pair of electrons by 2. So bond pair of electrons, how many electrons by which oxygen is bonded but to nitrogen? So 2 for each bond. That means 4 for double bond. So minus 4 by 2. Is it clear? Total number of valence shell electrons of oxygen is 6, that we know from the atomic number and electronic configuration of oxygen, minus lone pair of electrons. How many lone pair of electrons total? Not lone pairs. Lone pairs are 2. For this oxygen atom, but lone pair of total lone pair of electrons 2 and 2, 4. So we write 4 over here, minus bond pair of electrons. This oxygen is bonded to the central atom nitrogen by double bond, and each single bond means 2 electrons. So double bond, it becomes 4, double bond pair of electrons by 2. So 4 by 2, we are getting 6 minus 6, that is 0. So when oxygen is connected to the central atom by double bond, its charge is 0. So formal charge for this oxygen atom is 0. Next we come to the central atom, nitrogen. We number it as atom 2. Same formula we are going to apply. What is the valence shell of nitrogen? Valence shell electrons of nitrogen 5 minus lone pair of electrons. Lone pair of electrons over here 6. We are left with 2 lone pair of electrons that I have missed out in the previous structure which we have done, Lewis structure. So lone pair of electrons over here we are having 2. Not lone pair of electrons. So when we are writing lone pair, it is basically 1 lone pair. And lone pair of electrons, total lone pair of electrons, we write 2. Then minus bond pair of electrons. So bond pair of electrons, you see here, nitrogen, how many bonds surrounded by 1, 2, 3? Total 3 bonds. So nitrogen is surrounded by 3 bonds, or the central atom we can say connected to the 2 oxygen atoms by 3 bonds. So we are having for 1 bond 2 electrons. So for 3 bonds 6 electrons by 2. So minus 2 minus 3, that is equals to 0. So from now, from the concept of formal charge, we come to know that when nitrogen is surrounded to other atoms by 3 bonds, whenever we get nitrogen with 3 bonds, nitrogen will have the formal charge as 0. Whenever oxygen is connected to other atom by 2 bonds, the charge will be 0. Next we come to atom 3, that is the next oxygen atom. So total number of valence electrons will remain same, that is 6 minus lone pair of electrons. Over here, how many lone pair of electrons? 6. Lone pairs are 3, lone pair of electrons, total lone pair of electrons are 6, right? And then oxygen is connected to the central atom by one single bond. That means over here we are going to write 2 by 2 minus one pair of electrons. So how much we are getting? 6 minus 1. So that means minus 1, right? So this oxygen is carrying one negative charge, and that is why while we are drawing the structure of Lewis dot structure of nitrite ion, we have given oxygen connected to single bond, connected by single bond to nitrogen, carries one negative charge, right? So next we are going to show for nitrate ion NO3 minus. Again, step 1, choose the central atom. What is our central atom? Central atom is definitely nitrogen, or we can calculate along with that Q. What is Q? Total number of valence shell electrons. Total number of valence shell electrons of the species. And how do we calculate? Central atom. This is central atom, nitrogen. So total number of valence shell electrons will be, for nitrogen it is 5, there is only one nitrogen atom. For oxygen 6, 3 oxygen atoms, 6 into 3, and carrying one negative charge, so 1 electron. So 18 plus 5, 23, 24 electrons. So value of Q is 24 electrons. Then next, what was our step 2? Step 2, we have to draw the skeletal structure with the central atom connecting the corner atoms or terminal atoms by only single bond, that we have shown it. This is our skeletal structure. Next, third step, we have to calculate what? Bond pair of electrons, right? From the skeletal structure, we have to calculate the bond pair of electrons. How do we calculate the bond pair of electrons? Nitrogen is connected to the corner atoms by 3 bonds. That means 2 into 3 equals to 6 electrons. One single bond means 2 electrons. So 3 bonds, 6 electrons. Therefore, lone pair of electrons, Q minus bond pair of electrons. If you remember, we have done the steps. So what is the value of Q? 24 electrons. We have already calculated in first step or second step. 5, 18 plus 5, 23. Yes, right. So minus 6. Yes, 18 electrons. So now these 18 electrons we have to use in completing the octet. So how do we complete the octet? First corner atoms, and then the remaining ones goes for completing the octet of the central atom. So we'll see. Nitrogen, In the skeletal atom, 18 electrons. So lone pair of electrons equals to 18 electrons. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. For this oxygen, 1, 2, 3, 4, 5, 6. So each of the oxygen atom, we could see the octet is completed. 6 electrons as lone pairs and single bond. 7, 8. For this oxygen atom, 6 electrons, 7, 8, right? So in this way, we could see that each of the oxygen atom has fulfilled its oxygen. But what about nitrogen? We have used up all the 18 electrons in fulfilling the octet of oxygen atoms. Then what about nitrogen? Could we complete the octet of nitrogen also? Let's see. 1, 2, 3, 4, 5, 6. No, we could not. So in this case, what we are going to do? Convert one of the lone pairs from one oxygen atom into a double bond. So that we'll see how do we convert. Now you see, we have completed the octet of all the individual atoms with the central atom as well, including the central atom. See, for starting from the corner atoms, this oxygen atom already octet is fulfilled. For this oxygen atom, octet is being fulfilled. 3 lone pairs, okay, that means 6 electrons and 1 bond pair, 8 electrons. And for this oxygen on the right, 2 lone pairs, that is 4 electrons and 2 bond pairs. So we have fulfilled the octet of oxygen. And for nitrogen, the central atom, 1, 2, 3, 4, 5, 6, 7, 8. So this is the Lewis dot structure of nitrate ion. So as we have learned from the formal charge, when nitrogen is connected to oxygen, or rather we say oxygen is connected to nitrogen by one single bond, then it carries negative charge. We come to know it as we go on doing it, and practice will make us more proficient. When oxygen is connected to the central atom by a double bond, it carries no charge. Charge is 0. And again this oxygen will carry negative charge. Why? Because it is connected to the central atom with nitrogen, that is with one single bond. So let's verify it by applying the formula of formal charge once again. What was the formula? We keep on writing the formula: valence shell electrons minus lone pair of electrons minus bond pair of electrons by 2, right? As we keep on writing the formula, we get more familiar with it and we do not make mistakes. So first let us take for this oxygen atom, oxygen 1, right, oxygen 2, oxygen 3, and definitely for nitrogen also, nitrogen 4 we can take. So for oxygen 1, oxygen on the left, we get valence shell electrons of oxygen is 6 minus lone pair of electrons. Lone pair of electrons on the left oxygen, it's 6 only, minus bond pair of electrons, one single bond, so it's 2 by 2. So you can see it's minus 1 according to the concept of formal charge from the calculation that we have got from the formula of formal charge. Oxygen is carrying one negative charge, and this is the reason when oxygen is connected to the central atom by single bond, it carries always one negative charge. Now let's come to oxygen 2. Same, valence shell electrons minus lone pair of electrons, same as that, this one only, and we get 2 by 2, that is equals to over here minus 1, right? So this oxygen is also carrying one negative charge. Finally we come to oxygen 3, the third oxygen. So the oxygen on the right is connected to nitrogen by double bond, we could see. So let us apply the concept of formal charge. Valence shell electrons 6 minus lone pair of electrons. How many lone pair of electrons? Lone pairs are 2, that means 4 electrons, and bond pair of electrons, bond pairs 2 means a pair of double bond. So we have got 4 by 2. that is equals to 0. So now we can say when oxygen is connected to the central atom by double bond, its charge is 0. Now next we come to nitrogen. See, nitrogen is surrounded by 4 bonds. So what should be its charge? Let us calculate it from the formal charge formula. So valential electrons of nitrogen is 5 minus lone pair of electrons. Does it carry any lone pair? No, it doesn't carry any lone pair. So 0 we write, minus bond pair of electrons by 2. So bond pair of electrons 1, 2, 3, 4. How many bonds? 4 bonds, that means 8 by 2. That is equals to plus 1. So when nitrogen is connected to the corner atoms, terminal atoms by 4 bonds, its charge is plus 1. So now we can say that formal charge, we are showing the charge on the individual atoms on the ion itself. So from this, will you be able to draw the structure, whatever idea you have got so far? Will you be able to draw the structure of CO32 minus SO42 minus PO43 minus? Yes. Just apply the rules for step 1, step 2, step 3, step 4. You will get the correct Lewis dot structure. If you are confused with the charge carried by the individual atoms in the anion, you can calculate it from the formula of formal charge. So try it out. So I think you have drawn the Lewis dot structure of carbonate ion, sulfate ion and phosphate ion, and now we are going to see how we prepare the Lewis dot structure of this. So definitely the central atom, let's choose the central atom. What is our central atom? Central atom is carbon. Okay, now next is we will draw the skeletal structure. You can take it first. Let us draw the skeletal structure. We have 3 oxygen atoms connected to the central atom by single bond only. Then calculate Q. What is Q over here? Total number of valence electrons. Total valence electrons of the species, and our species is carbonate ion, right? So for carbon it is 6. How many oxygen atoms? 3 oxygen atoms, sorry, for carbonate. Oxygen 6 into 3 and 2 negative charge. So over here we add plus 2 electrons. So how many we are getting? 18 plus 4, 22, 24 electrons, right? So this is the total number of valence electrons of the species, and then we have drawn the skeletal structure. Now these valence electrons, from here we have to calculate. Next step will be bond pair electrons. How do we determine the bond pair electrons? From the skeletal structure. So 3 single bond, as we can see. So how many we are getting? 2 into 3, that is 6 bond pair electrons. Now lone pair electrons, therefore lone pair electrons equals to Q minus bond pair electrons. We are writing each and every step so that things become more clear as you go on doing it. We are having 18 electrons, right? So lone pair electrons are 18 in number. Now these 18 electrons we have to utilize in 2 ways. How? First, satisfy the octet of corner atoms. First, satisfy the octet of terminal atoms, that is oxygen, and then followed by the central atom. So let us see 1, 2, 3, 4, 5, 6, 7, 8. This oxygen atom, its octet is completed. 1, 2, 3, 4, 5, 6, 7, 8. That is, we are having 3 lone pairs and 1 bond pair. So oxygen is having 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now each of the oxygen atom has fulfilled its octet. That means we have used up all the 18 electrons. But what about carbon? Carbon, we have to satisfy the octet of carbon also. So what we do, we convert one of the lone pairs into a double bond, right? Now you can see each of the corner atoms, 3 oxygen atoms, has satisfied its octet. At the same time, carbon has also satisfied its octet. So there are
How many electrons? 1, 2, let us see. How many electrons for carbon? 1, 2, 3, 4, 5, 6, 7, 8. So central atom has fulfilled its octet. Let's take the doubly bonded oxygen, carbon oxygen. How many electrons? 1, 2, 3, 4 and bond pairs 5, 6, 7, 8. Again this oxygen atom 6 electrons as lone pairs, 7, 8. Finally with this oxygen atom same. So we put negative charge over here, negative charge. Oxygen is connected to the central atom by single bond, then negative charge. When oxygen is connected to the central atom by double bond, then no charge, charge is 0. You can verify the charge by calculating from the formula of formal charge. You will get -1 for single bonded oxygen, and for doubly bonded oxygen with the central atom, the charge, formal charge will come 0. So finally what can we write? This is the Lewis dot structure of carbonate ion. Now next we go for sulfate ion. SO4 2 minus, right? So what is our central atom? Central atom is definitely sulfur. Let's calculate Q. Total number of valence electrons of the species. For sulfur it is 6. Then for oxygen, how many oxygen atoms over here we are getting? 6 into 4, right? Plus 2 electrons. So 24 plus 6, 30, 32 electrons. This is the value of Q. Then we'll draw the skeletal structure by only single bond, right? As sulfur is the central atom, we draw the skeletal structure. All the 4 oxygen corner atoms or terminal atoms connecting by single bond. Then bond pair electrons. How many bond pair electrons? 2 into 4, 8 bond pair electrons. Why 2 into 4? There are 4 single bonds and each single bond is 2 electrons. Therefore lone pair electrons. Q minus bond pair electrons. So what we are getting? 32 minus 8. We are getting 24 electrons will be as lone pairs. Now these 24 electrons we have to utilize in 2 ways. First, satisfy the octet of the terminal atoms, right? And then the central atom. So let's see how do we satisfy the octet of terminal atoms. Sulfur, once again we'll draw the structure. 1, 2, 3, 4, 5, 6, 7, 8, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24. Now see here, each of the oxygen atom has fulfilled its octet, right? Do you think the structure is correct? No, the structure is not correct. Why? Atom's central atom has the tendency to remain in its maximum covalency state. This we have discussed while discussing the rules before we start with Lewis dot structure. This is the case of that. Central atom, sulfur, phosphorus, some elements will have the tendency to remain in its maximum covalency state, and maximum covalency of sulfur is 6. For phosphorus it is 5. So what we do? We convert one lone pair of electrons into a double bond. Again, one lone pair electrons we convert into double bond, right? Okay. And for the single bonded oxygen with the central atom, we put a negative charge. Oxygen is connected to the central atom by double bond, charge is 0. Oxygen is connected to the central atom by double bond, charge is 0. You can verify it by the concept of formal charge. Now you see, for central atom, our central atom is sulfur over here, right? This is our central atom. Let us see how it has fulfilled its maximum covalency. 1, 2, 3, 4, 5, 6. So this is the exact structure of sulfate ion. Okay, so we'll draw it once again neatly. Sulfur, in this manner we can draw the Lewis dot structure of phosphorus also, or we can write in this way. In books you will be finding. Two minus. This is minus 1, so minus 2. Right? Then next for phosphorus, PO4, 3 minus, right? So what is the central atom? Central atom is phosphorus. So let us calculate Q for phosphorus. We have 5, then 6 into 4 plus 3. So over here 24 plus 5, 29, 32 electrons. Okay, so 32 electrons. Then we'll draw the skeletal structure. How do we draw the skeletal structure? By using only single bond. So this is our skeletal structure. From there we calculate bond pair electrons. As there are 4 bonds, 2 into 4, 8. We calculate lone pair electrons. Same steps. Q minus bond pair electrons, that is equals to 32 minus 8 equals to 24 electrons, right? Now these 24 electrons we have to utilize in 2 ways. First, satisfy the octet of corner atom, and then followed by central atom. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 into 4, 24. 24 we have already utilized. But is the structure correct? Definitely from the concept of formal charge, if oxygen is connected to single bond, then minus 1, minus 1, minus 1, minus 1. Then it should be minus 4. But over here we are getting what? Minus 3. So that we can make out the structure is not correct. Simultaneously, the other thing is that this is the central atom, phosphorus. Phosphorus maximum covalency is 5 because of 3D subshell. It can extend its covalency. Its maximum covalency is 5. So let us see how we can satisfy the octet or the maximum covalency of phosphorus. We'll convert one lone pair into a double bond. Calculate the charge on the individual atoms. Formal charge. Say oxygen 1, oxygen 2, oxygen 3, oxygen 4 and phosphorus. You will get minus 1 for oxygen 1, again minus 1 for oxygen 2, oxygen 3 as well. Oxygen 4 means phosphorus is connected to oxygen by double bond, so no charge. Therefore, you will get it valence electrons minus lone pair electrons minus bond pair electrons by 2. Right?
So this is the Lewis dot structure of phosphate ion. You can draw the structure again as neatly. See, we'll take phosphorus, okay, 3 minus. Now each of the corner atoms have satisfied its octet, each of the oxygen atoms, terminal atoms. At the same time, the central atom phosphorus has also satisfied its maximum covalency and it can accommodate 10 electrons due to the presence of 3D subshell. So 1, 2, 3, 4, 5. Maximum covalency of phosphorus is 5, right? Same for sulfur, it is 6. So sulfur can expand its octet, phosphorus can expand its octet. Phosphorus can accommodate 10 electrons and sulfur can accommodate 12 electrons.